So the next speech is from Oskar Kaplun. I know Oskar since his first day in the CAN automation. He started in CAN automation in 2009 as a technical secretary. And as such, he is responsible for CIA working groups and develops together with experts from external companies specifications for CANopen, especially for CANopen testing, CANopen application layer functions and such. Beside that, he is responsible for the technical support of such technical specifications and inquiries, and he's carrying on the CIA plugfests. And also he is responsible for the CANopen device conformance and interoperability testing at the CIA testing laboratory. So please, Oskar, go ahead.
So I hope you can see me and hear me very good. I will start straight there. I've just given me a short overview of what my activity at CAN Automation. So to point you out why I'm doing this presentation today, besides supervising the CAN Automation special interest group various, I'm doing also testing, actually CANopen testing, and now also CANopen FD testing. So then I would like to share with our experience and what we did, what we do, and what we will do as well, since the topic says today and tomorrow. So for testing, CANopen FD application layer, as the previous presenter, Mr. Schwager said, and Mr. Seltwanger, we do have already 2 application layers based on CAN. This is CANopen and CANopen FD. My topic is addressed to CANopen FD and its application layer, which we are testing. We do not test data link layer, we do not test physical layer, but purely application layer itself. But the point is of this slide, for example, is to say that CAN FD is the underlined data link layer, which is using CANopen FD. Has some big advantage or some additional advantage over the classical CAN. It offers 64 data bytes and also some higher speed concept, but we're concentrating ourselves on payload. And payload affects actually which new communication services will be available, which we cannot have in classical CANopen. So this means actually it has this corresponding impact on that. And if we take a look into the internal device structure, just a couple more slides about this general concept, we see the object dictionary, as the previous presenter already said. The object dictionary is a database where device itself from application software you can see and protocol stack take the parameters. So they are not stored in protocol stacks, and application specific parameters are not stored in application software. They are stored in a single modular, making a modular structure in a single database called object dictionary. So this simplifies, of course, the access to the device, but the device is considered as a black box itself for the testing. So we don't test protocol stack and we don't test application software itself, and neither do we object dictionary alone. So we do the whole piece as one. Additionally, in contrast to people here with a different background who are doing their own CAN application, CAN FD, CAN Excel application layer, we have this CANopen standardized. CANopen FD goes also in this direction. It has a unique way to identify the device, not by the message ID, but there is certain specific device device identification, and it requires actually a configuration of it in a network to know which device I will go into address and test. So for this one, we have multiple methods to do so, to design actually how do we assign this node ID. You're welcome to visit or to attend our CANopen seminars or webinars to learn how to do so. I'll concentrate on CANopen FD specifics. They support all these methods, and beside that is also a very specific software-based called layer setting services configuration. The specification itself is also for CANopen FD. They are different, CANopen and CANopen FD one, because they are different concepts, slightly different concept, additional concepts embedded into this. That is to know with the testing itself. CANopen FD bit rates are different than in CANopen. CANopen we have 8 bit rates for the choice, and at least one shall be supported. In CANopen FD is a little bit complicated, so we need mandatory pairs of bit rates. So every device is actually coming up with these mandatory pairs, since CANopen has, as CANFD, has nominal bitrate and data bitrate. So the reasonable combination that work perfectly in a perfect combination with each other, already defined in their bit timing. And there is a table, pictures here provide this assignment. The picture can be found in specification 1301. And you know that every device you get in hand has always pre-configured bitrate, so you never have problems with communication in a network, assuming the assignment is the same, and assuming that the device is set to the same bitrate, so you start immediately to communicate. This is to consider also in setting of the device, preparing this for testing. So beside that point, also for CANopen FD, we had CANFD, we had already the specification provides recommendation, assignment, and specification, how to do device and system design. This is what is not present or available in the standard for CANFD, CANFD. And this is why you have to check this out. However, this more or less affects interoperability testing of the devices, but nonetheless, the bit timing recommendation, the network topology, and so on, those recommendations are in there. And they could be at least partially used in CANopen FD static testing, which we are application testing, which I do, because we need some dynamic parameters of the network to simulate this behavior for certain tests. There are CANopen FD protocols, which are similar to CANopen protocols, or classic CANopen protocols. There's nothing changed on the number of a type of the protocols. We have point-to-point connection, we have process data object, we have universal service data object as a point-to-point connection, and so on. Emergency, some network management. CANopen, classic CANopen offers network management, the same does also CANopen FD. There are some certain limitation, a reducing of the number of certain protocols in there. On the other side, based on a payload, larger payload of CANFD, there are certain impacts on transport CANopen FD protocols, which shall be tested, of course. Those are the USDO and PDO, and these are the protocols we are looking into briefly before we start to go with the real topics of testing itself. So, universal STO. In CANopen, we have classic STO, point-to-point connection. Some possibilities we can do, download a big, large chunk of data, can transmit as 32-bit, maximum 32-bit small data, whatever it means. Universal STO replaces STO in CANopen FD and does have some completely new and additional functionality which was not available for classic CANopen. Those are actually beyond the unicast as STO was used. We have multicast, so means for one-to-many, and a broadcast. So actually we can do either configuration or a software download immediately into multiple devices at the same time. Also, we have, as usually, certain protocols for short number of data, up to 58, about 58 data bytes due to a CANFT payload, and large download is bulk transfer and segmented transfer. So additional one is allowed parallel segmented parallel access to the very same device, actually, to its so-called very same server. You can start several requests and they are all completely identified, and you know every time which ones actually hang in there, and the device responds also with this special signature, which you could find out in the specification 1301, that you, to the certain point of time, you know what is the request done to the device, from which one and which request was it actually, by numbering it in a certain way. This is not available in classic CANopen in STO, so it is different functionality which allows, which requires also additional testing. So this increases actually almost exponentially the test itself, but we try to keep it at the range. We have also process data object. Nothing changes in there that big. We have no RTR frames, so it reduces number of tests, probably to a certain degree, but we still have a PDO test to check it. And so we come up with this point. Why should we have it actually, since it could be done manually or whatever? So the decision made by CA Business Committee, which actually looks out for how to spend money of our members to the certain sensible and useful manner on request of our members as well. And it decided actually that CANopen FD conformance tests should be mandatory. The second point is it requests also a reliably working testing tool. So these 2 points, these 2 goals we are moving toward. And beside that, based on those requirements, we agreed to discuss that we need a reliable testing environment, a reliable test bench that is repeatable, reproducible test, self-explainable test, covers all necessary functionality of CANopen FD application layer communication profile. And finally, it should, of course, provide useful hints to help improve the once CANopen FD implementation. So the plan looks very simple, and it is, and it should be, but this is not that trivial while we're developing it. So the plan is to design first the test tool as requested, a test plan for this, what to test actually, what functionality should be tested, and based on it, design a test plan. So that is, of course, send a question in crowd. What are the devices testable in CANopen? CANopen has several major device categories, the same as this classic CANopen, same as in CANopen FD. We have a controller, former master device, a manager which manages the network itself, could be manage a network. we have a simple device, or maybe not that simple, which is managed by the manager. And there are some classes, a class of devices which are actually having one or two capabilities of the controller, like a self-starting device, like kind of network management operator, configuration tools, or whatever. Since we haven't decided what to test, but this is a table, a list of these classes of devices, I've done a short overview. Which of those are testable, which should be actually tested, because the main reason of testing is lays in there. So the controller will be a more complex part. It is actually testable. We have no tests are actually planned the same way as is for CANopen, for a classic CANopen. But maybe this is changes in a time for that. But as I said, this is a little bit complicated. We need some kind of responding tool which generates some response from the master and receives feedback from this server device. This will be a little complicated. So on the contrary to that, the server device, test can be defined. It is fully testable to a certain degree. Most of the tests will be suffice there, and a testing environment will help out with that. That's the main reason, main point of doing this. The device is like controller capable with its capabilities of this manager will be to a certain degree testable. If I disable the master manager capabilities, controller capabilities, still it is offers a limited range of for testing in there. So based on this all stuff, we could start the testing itself, but it's presenting certain challenges. So certain challenges, we don't know, as I've started in a first couple of slides, I said we consider the device as a black box because we don't know what is inside. We check the response from the device. How does it work? Basically, in where, how can we test it? And that will be black box. And the second thing, a black box testing considers that we have a specification and we just test the response from the device on this. By this one, we could recognize device errors against specification, which is the main reason for this testing, and a possible specifications error, which we could fix on hold. So the white box testing is not involved here. It's a little bit more complicated. I need to know the insides of the device. It is more or less for the upper test, and for this test, which will be designed by some company for their devices. They want to design their own CANopen FD tests. So, and design the systems, that will be a white box testing will be sufficient for that. But for now, we don't know who will use our test and what is the device is sent to us for testing, that we will test the device. Then we said there will be black box testing. So the second one was actually to use test scenarios versus test cases. So which we see the next slides, what is going on about this, why we do so. The test scenarios just provide a general description, very, maybe not very basic, but very general in its content, while the test cases define more specific, more detailed, more singular steps for testing. That causes, of course, a much larger test catalog as for classic CANopen, considering that we have some more tests. With this, if we use the test cases, but we're going this way, so we want to test thoroughly all this one. And the last in this slide is the latest, is a test bench, actually test environment. Would require some working tools. Beside this is a request to have an automatic tool, to have a tool to handle this. For whatever reason, if this tool is not yet there, we still need tools for data-intensive tests, such as object dictionary test for hidden object, or maybe reading back all the parameters, whatever, such as a part of the test. Is time and data consuming, and so requires usage of the tool. So a tool, any tool suitable for this reason might be involved in this testing. So without a tool, it will be complicated to do. The second one for testing challenges is actually protocols. How much should we test then? How much do we test? So I do the comparison actually between CANopen FD and classic CANopen. And as you can see from the first one, we have transport protocols such as USTO and STO at classic CANopen. They are twice more mandatory, many more mandatory protocols, which are anyways have to be implemented. This means I have to design several more tests, and that means the larger test catalog, which means the test plan will contain more tests as is usually was done for CANopen, classic CANopen, but it was expected actually. The point is to keep those tests reasonable to a certain degree, not to overload the whole testing procedure whatsoever, to make it in a reasonable time. So, oh, sorry. Configure several points for testing. We have configuration of the point-to-point communication or broadcasts such as USTO. The configuration is done not with the parameters and 1 byte of the data frame, but is done inside of the data frame. Data frame is enormously big for this reason, so we use a couple more bytes to make completely configuration of USTO, allowing some certain advantages against the STO, but we have to verify over the data frame. We have to verify the proper configuration of this, and there are many more tests are required for this reason to check this out. There are, of course, based on this one, also multiple USTO clients available and servers inside of a single device, which we could do in a very short way. But this means also many tests against a single STO server, which has configured, and the testing is done only between the client and server at most. There is also the sequential parallel access I mentioned before, that you could send multiple requests around. That should be tested as well. Other challenges are that the test plan may be not ready. It's not ready yet, but will be soon. So for this reason, we have to come up with another solution, with a more pending solution, and that technical committee of CAN automation requested to design a checklist in a way of temporary solution until the test tool plan is done and test tool is designed. There should be also appropriate test environment designed for this kind of testing, for this manual checking. And we have to consider the test environment for how design a test environment for the upcoming test tool. Just to point you out, this is the information, what is the state update and actual stage of development, what we have now. We have done many of those things, but there are still some things to do. The specification, which is base for testing, against which we are testing, is released. 100% completion, the first version is done. The second version is on the way, but it is to be considered how we do so. Either we test, currently we test against the version 1.00. Manual checklist is designed and is approved mostly. There are certain few tests which are currently yet in development, but the check procedure is already here and a test environment is ready. We have already a CANopen FD device which is in testing. Currently, we also design test plan. We have many of the protocols designed. Most of those were USTO. Since this, I've written that is 70% completion. We hoped to achieve some more by the end of the year, that we complete this finally. And that we haven't started with the test tool since there is nothing yet as a test plan available for that. Well, then in the next couple slides, I would like to present just briefly what is challenges during checklist procedure and what is coming up with a test tool when we have it and with a test plan. It's more the challenges and considerations as well. So testing we do actually manually requires the test interface, requires the CANFD interface and the tools. We have it already, and we have arranged a test environment. We have a manual procedure. We'll go through this procedure, and the test procedure we don't have that much time as for test tool. So we said we design this on a base that is test scenario based. So the just general description of the test. Most CANopen FD protocols, mandatory and not only mandatory, but all required services which available in every device, which we can cover with this test. Most of CANopen FD devices coming on the market. Total number of test scenarios 29. Total time will be a little bit more. The test bench, test environment for this, as I said, will be a test environment. It is a test environment ready for this. The reason for that, the test environment should be simple, so that not only can automation, but the others could check out, pre-check the device before sending us for testing as well. The simple message logger allows us to generate some messages to receive the feedback from the device. And as I said, we need some tools for generating and reading back the data from the object dictionary. We have this tool, so it is a big help for us. The tests are actually reproducible. We've written them the way, the scenarios. We've designed also how we test the device, and you can reproduce. The tests are actually reproducible and covering all the requirements necessary from the specification itself. So the test plan, progress, and a tool, we have the same, almost the same with the automatic test tool. We don't need any specific various tools which we have to test one by one, so it will be integrated probably. And we don't waste a time because the testing is semi-automatic, more automatic one. So I just configure and then start the test, and it goes completely from itself. The tests should be detailed since we completely thoroughly test the devices, but still we say there will be mandatory and some optional protocols and communication services we test as a response from the device, but we employ here test cases for detailed and for this case that you could follow up what is going on in this device. Every time you know what is going on with each single test, you can follow by each single test set. The total test number of test cases are slightly above about 300, but you should consider that most of them, 2/3 of those, are falling into USTO, because USTO protocol is much bigger than the ISTO. It offers some additional functionality, and that has to be tested as well. Test tool bench is actually the same way designed as for the manual test procedure, manual check list, but we have to consider some certain points. The test should be reproducible. Every time you start a test tool, it should provide reliable and reproducible results of this. In the next couple of slides, time is a little bit up, but I would like to show you how does it look like. Checklist, we have a form for this. Our field is up, 29 tests described like this. In a field, I describe either test is passed, failed, or not applicable. It could be also happening. For base protocols, which are mandatory anyways, and which could provide a certain information if the device supports CANopen FD whatsoever. The test cases are designed actually more detailed. In there, we have not gone to do design is somehow up to ourselves. So we use the already existing structure for description of the test cases. And here I have some examples for USD and PDO tests. For PDO, it's only a piece of the test, but you can see it's kind of pseudocode. I describe the procedure, and the procedure in case of USTO is a very detailed test cases. Procedure in case of PDO and other tests like object dictionary and so on are more bigger test cases, not that atomic as the USTO, but we don't need it in this case. But we are more detailed, and you can following up what is the single test does also in a conformance testing. A couple more slides about device description. We need it actually for test the device. We have also specification which is released.
Oskar,
and the device are designed actually with this. And I do have shown here some pictures. How do we do this in specification? So you design the scheme-based XML scheme based on the specification on the left side, and right side you see the XML scheme by itself designed in XML format. The other thing is actually how does it look finally based in a specification? How does it look like in a real life when I have a device description based on this scheme? Their tools are already available, so we can integrate them and can at least use these tools for manual checking and future up in our test. So the final one will be about the test bench. We use the lower test. So we don't have capabilities for checking application itself. So we do lower test, same checklist as a test tool will cover it up. And finally, this is a short
Oskar,
summary which you can see.
Interrupt here. Sorry,
yeah.
I have to interrupt here because we are
having next
really over time. So if you have got only one slide left, it's okay. Otherwise, we have to pass to the next session. Sorry for the interruption.
Yeah, just a minute, just summarize this one and we go next. As I said, we have a checklist. Manual testing is available. We have already device we are testing. We have device description available. Test tool are available for testing of the device descriptions. There is a test bench for manual checklist. We're working on test plan, and we soon will be available, will be possible to have a test tool. I hope so. At least a test plan, then a test tool. Thank you very much for hearing me.